Evet arkadaşlar. So let's start our lecture for today. So last week we are done with the physical layer, which was the last layer in the OSI model. Now we are going to move to the chapter 6, which is wireless and mobile networks. So let's look at the outline. So today we are going to cover two topics. The first one is the wireless technology. The second one is the mobility. How do we handle and manage the mobility in the wireless networks? So let's start with the wireless technologies. First of all, we're going to start with the main principles of the wireless links and characteristics such as CDMA. And then two dominant technologies. The first one is the Wi-Fi. The second one is the cellular networks such as GSM, 3G, 4G, and so on. So once we are done with the wireless technology, then we are going to move on to the mobility aspects of the wireless networks. The main principles, including the addressing and routing to the mobile users. More specifically, we're going to talk about the mobile IP and the handling mobility in the cellular networks, mobility and the higher layer protocols, and then we're going to done for today. So let's start with the main components of wireless networks. As you see, we have a different kind of wireless host or mobile devices. Can be smartphone or laptop or tablet, smartwatch, and so on. So one of the first component is called wireless host. And this can be laptop, smartphone, tablet, as I mentioned. These wireless hosts, they run applications. So it can be a mail application or some bank application and so on. And these wireless hosts can be in two forms. One of them can be stationary, which is, it doesn't move, is a non-mobile. And the second one, it can be a mobile device so that you can take with you and, move around. So therefore, wireless is different than mobile. So wireless doesn't always mean mobility. It can be a wireless, but it can be stationary, not movable device. The second component of wireless network is called base station. And this base station, as you see here, is connected to the wired network, such as the internet. And one of the main function of this base station is to relay the packets from mobile to the internet and vice versa. So it exchange or relay the packets between the wired and the wireless host in its area, of course. So it depends on the technology. In IEEE 2.11, namely Wi-Fi technology, such base station is called access points. In GSM, it's called cell, towers and so on. The last component of wireless network is called wireless link. As the name implies, it connects the mobiles to the base station. Also, it can be used as a backbone link to connect the base station as well. Because this is a limited resource, so we need a multiple access protocol so that we can coordinate the link access. And we covered this multiple access protocol last week, if you guys remember. And the wireless link performance, it depends on the distance, of course, transmission distance. That's why the data rate can be vary depending on the distance and the channel environment. So let's look at some selected wireless technologies and their characteristics. The y-axis is the data rate in terms of megabit per second, and x-axis is the distance in terms of meter or kilometer. So we have different wireless technologies such as IEEE 80 dot, such as 15, like a Bluetooth, and the range is about it's utilized mostly for the short range, such as the indoor application from 10 to 30 meter. And then we have 80.11b, A, G, N, AC, and so on. These are the Wi-Fi standards that also used for the indoor application or short range. And the data rate can be vary from 5 megabit per second up to 200 megabit per second. And these are the indoor technologies. Let's look at more like outdoor, like a long range or mid range technologies, such as the GSM is called 2G. 2G technology, we have different technologies such as IS-95 from US, CDMA, and GSM. And we have 2.3 UMTS wideband CDMA, CDMA 2000, and we have 3G technologies, CDMA 2000, 4G, LTE, WiMAX, and so on. So depend on the application and the environment, the range, data rate, you can select different wireless technology. Okay, so we have two main mode of the wireless network. The first one is called infrastructure mode. So in this infrastructure mode, we have a base station, and base station is responsible for connecting the mobile devices to the wired network infrastructure. And since these mobiles can be, since this wireless host can be mobile, so they move around like this case. For instance, you are in a car and you're talking over the mobile phone, and the car is moving like 60 kilometer per hour. So you need an handoff to hand over your connection from one base station to another base station, so that we can provide a consistent service. So that process is called handoff or handover mechanism, to hand over your connection from one base station to another base station while you are moving. Another mode is called ad hoc mode. In this case, there's no base station or central unit. Nodes can only transmit to other nodes within the link coverage, of course. And the nodes is responsible to organize by themselves, route among themselves. So there is no any kind of base station or central authority to organize this network. So this mode is called ad hoc mode. So let's classify these wireless networks in terms of number of hops as well as the modes. So we already talked about infrastructure, and if we have a single hop, that means in this infrastructure there's a base station, and the base station is responsible to connect wireless host, smartphone, mobile device to the wired networks, to larger internet. And each there's just one hop between mobile device and the base station in this case. That's why we call single hop. And ad hoc mode, no infrastructure mode. As the name implies, there's no base station, so no connection to the larger internet. So they just talk among themselves, such as the Bluetooth network. And this also is a single hop. Let's look at the multi-hops infrastructure mode. So in this case, as the name implies, of course, there is a base station and is responsible to connect the wireless host to the wired networks. And the host in this case may have to relay through several wireless nodes. So they hop from one node to another to reach to the base station. So it's not like a single hop in the previous case. So in this case, we may have a multiple hops so that a wireless host that is far away from the base station can get an help from another mobile device and then relay to the base station. Such wireless network is called multiple hops. And we have technology which is called mesh network. So mesh network can provide a multiple hops connection. The last one, multiple hops ad hoc network. There's no base station, so no connection to the larger internet. So in this case, one node, one wireless host that is far away, that in order to reach to another wireless host, it may get an help from other nodes so that it can hop and relay this information or packet to another packet, another node. So this is called multiple hosts ad hoc networks. So in summary, in this type of network, a wireless host in this network may have to relay to reach other wireless nodes. To give an technology in this case is called MANET, Mobile Ad Hoc Network, or VANET, Vehicle Ad Hoc Network. These are some examples in this type of network. Okay, these are the main principles of the wireless things. Let's look at some characteristics. Okay, because wireless link is, you know, there are some differences between wireless link and the wired link. When you say wired link, it can be an Ethernet cable or a fiber optic cable and so on. So in wireless link, you know, we have a decreased signal strength because the distance is dependent on the distance. So the radio signal attenuates as it propagates through the objects, and such decrease is called path loss. So we, you know, lost the strength as we move from the transmitter to the receiver. Such mechanism, such loss is called path loss. Another important problem in wireless links is the interference from the other sources. For instance, in 2.4 gigahertz, which is an unlicensed band, and different technology can operate in this band. That's why they share, and they can interfere each other. So that's why we need to take care of this interference problem. Another main issue is the multipath propagation. So when we radiate the signal from the antenna to the air, so as you know, the radio signal, they can reflect or diffract or scatter around from the object's ground, and they can arrive to destination through the different paths, and this is called multipath propagation. So this multipath propagation can be considered as an disadvantage or advantage. So, but if it's a disadvantage, we need to take care of that. And one of the important performance parameter in wireless link is called SNR, which stands for signal to noise ratio. And larger SNR is desired because it's easier to extract the desired signal from the noise. That's why we desire to have a good SNR or the high SNR. So this is a figure for the SNR versus the bit error rate trade-offs. And as you see, depending on the modulation that we use, if you want to have a like 1 megabit per second, you can utilize low order modulation such as BPSK. And then you can, if you want to increase the data rate, you can use the higher order modulation such as the QAM16. And then if you want to have more data rates such as 8 megabit per second, then you can utilize QAM 256. So the performance of this different modulation is given in this figure, as you see from here. So given physical layer, you can increase the power, and then this is gonna lead to the increasing the SNR. If you increase the SNR, as you see from the figure, you decrease the bit error rate. So we can use this later on. It's called adaptive rate adaptation. So depend on the target bit error rate, you can select a different modulation, because the SNR may change with the mobility. As you move around, your SNR can change. In order to dynamically adapt, you can change this modulation. So another problem in wireless network is called hidden terminal problem. Let's explain this. So you have let's say we have 3 wireless hosts, and one of them is A, the other is B and C. So assume that the B and A, they hear each other. B and C also, they hear each other. But A and C cannot hear each other because of this obstacle, these objects. So that's why A and C is unaware of their interference at B. So since the A and C cannot hear each other, if they want to talk to B at the same time, then they're gonna create a interference at the B, because they are not aware of each other due to this obstruction. So let's look at in terms of signal strength. And A and C, because they cannot see each other, they want to communicate with the B at the same time. So A transmit the signal, and because of the path loss, the signal strength decrease, and C cannot hear, but it still is a high level at the B. And the C at the same time, it transmits its blue signal. Of course, it decreases. So A, when it reaches to the A cannot detect the signal. In other words, it cannot hear the C. So that's why at this point space, at this point at B, both A and C, they create an interference. This problem is called hidden terminal problem. It's one of the most popular problem in wireless networks. So we said that we have a wireless link and we need to access this channel using the multiple access technologies. One of them is CDMA, which stands for Code Division Multiple Access. The basic idea here is we assign a unique code to each user from a code set. And in this case, all the users, they can share the same frequency at the same time. But each user has own chipping sequence or code. And so each user, it encode its information using this chipping sequence, which is unique to that user. So this CDMA allows multiple users to coexist and transmit simultaneously with minimal interference. Of course, under which condition? If these codes are orthogonal. So at the transmitted side, we encode the signal as follows. We have the original data, which can be text, video, or voice. We multiply with the chipping sequence. At the receiver side, there's a decoder, and so decoder is gonna extract this original data by inner product of encoded signal with its own chipping sequence. Let's give an example when we have a one single sender and one single receiver. So first of all, let's say D0 is equal to 1. This is a modulated signal. Let's say this is a bit 1. We are transmitting in the slot 0 times slot 0, bits 0, and the modulation is converted to 1. And we multiply with the 8 chip sequence. This sequence is 1, 1, 1, minus 1, 1, minus 1, minus 1. If you multiply this with 1, and you end up with the encoded signal of this, right? So in the next time slot, we transmit the next bits. Let's say this is the BPSK, so bit 0, and we multiply with the, because each sender has a unique code, we multiply the bit 0 also with this sequence. But this time we end up with this sequence, which is the encoded signal. So once we have the encoded signal, we transmit through the radio channels, and then we receive at the receiver. Now we need to decode this signal using the same chip code, the chip sequence. As you can see, if you multiply 1 plus 1, 1 plus 1 times 1, 1 times 1, and you'll see that you're going to have like 8 over 8, which is equal to 1. So we decoded this as a 1. Similarly, we received the second bit was this, and we multiply with the same chip sequence. So it's minus 1, minus 1. This is minus 1, this is minus 1, minus 1, minus 1. Minus 8 over 8 is equal to minus 1. So we decode it as a minus 1. So this is how we achieve the CDMA at the sender and the receiver. So let's look at the, in case of two sender, to see the interference effect. So that sender one is from the previous example. So sender one is trying to transmit bits 1 and 0, and sender 2 wants to send bit 1 and bit 1. And the chip sequence, the code for sender 1 is this: 1, 1, 1, minus 1, 1, minus 1, minus 1. And for the code for the sender 2 is different, as you see, is 1, minus 1, 1, 1, 1, 1, minus 1, 1, 1. So these two codes, they are orthogonal. So when you say is orthogonal, you multiply 1 minus 1, 1 minus 1, 1 minus 1. So If they are orthogonal to each other, when you multiply, it should end up with 0. So, as I mentioned in the previous example, you multiply each of these data bits with these chip codes, and then you add them up, you sum together, and you end up with this, encoded sum data bits. And then we transmit over, we transmit over the radio signal. So as you see, we received the whole information actually. Each receiver 1 and receiver 2, it received the whole sum information that include the information from the sender 1 as well as the sender 2. Now, as a receiver 1, it's my responsibility to extract only the sender 1 information and remove the sender 2. So this is gonna be done automatically when I multiply with my unique code. As you see, when you multiply with the unique code, you only extract your information, which is the sender 1 information, as you see. Any questions so far? Okay. So these are the main principles of the wireless link and its characteristics. Now let's look at two popular technology in terms of wireless network. The first one is the Wi-Fi. The second one is the cellular network that include the GSM, 3G, Wi-Fi, WiMAX, LTE, and so on. So let's start with the Wi-Fi. And this wireless LAN is called Wireless Local Area Network, and the industry name is called Wi-Fi. And it has different standards, starting with the 802.11b. Some of the features of these standards includes dual band that operates in both 2.4 gigahertz as well as the 5 gigahertz unlicensed spectrum. So when we say unlicensed, you don't have to pay any kind of money as an user to this spectrum. And it can provide up to 11 megabit per second data rate. And the technology that is utilized in the physical layer is the DSSS, which is direct sequence spread spectrum. And all hosts use the same chipping code in this case. And later on, we have different, this wireless LAN Wi-Fi standard evolved. So we have different standards, 11A, which can operate only at 5-6 gigahertz range. But now the data rate is increased from the 11 to 54 megabit per second. And then we have a 802.11g, which operates in both 2.4 gigahertz as well as the 5 gigahertz band. And the data rate is up to 54 megabit per second. Another standard is called 11n, which introduced a new technology, which is called MIMO. In other words, it utilized the multiple antenna technology. It can operate in both 2.4 gigahertz as well as the 5 gigahertz band. And the data rate can be up to 600 megabit per second because of this MIMO technology. All these different, and we have now it's still evolving. We have 11A, C, and then the name notation change. Actually, we don't call anymore 802 dot something. It's called Wi-Fi 6, 5, 6, and so on. All these Wi-Fi standard, wireless LAN standard, they use carrier sense multiple access collision avoidance for accessing to the wireless link, and all have base station as well as the ad hoc network modes. So let's look at the wireless LAN architecture. At the middle, of course, we have the base station, and this base station, in terms of Wi-Fi literature, in Wi-Fi literature, is called access point. And this group of network is called BSS, which stands for Basic Service Set in infrastructure mode, as you see, BSS1, BSS2. And in this BSS, we have a wireless host, which can be smartphone, laptop, tablet, and so on. And at the middle, we have access point. And this standard can support both infrastructure as well as the ad hoc modes. Let's look at the number of channels and how the first association happened in this standard. First of all, in .11b, which operate in 2.4 up to 2.485 gigahertz. This spectrum, like about 85 megahertz, is divided into 11 channels at different frequencies. And we have an admin for these networks. Access point administrator can choose the frequency for its access point. And interference is possible because this is an unlicensed band. Not only Wi-Fi, the Bluetooth, some cordless phone, other wireless technology, they operate in this band. So that's why these different technology can interfere each other. Even the Wi-Fi by itself can interfere due to the self-interference. And another one can be, at your home, you select one channel and your neighbor can select the same channel. So that's why your neighbor can interfere with your access point because using the same channel. So, okay, I have the Wi-Fi access point, Wi-Fi network, and my smartphone, let's say wireless host, want to access to the internet through the Wi-Fi. So the first process is called association. So my host, my mobile phone, must associate with an access point. So therefore, it follows the following steps. First of all, it scans channel and listen for the beacon frames that is broadcasted by access point, which include the access point name, SSID, and the MAC address. So we scan channel in your smartphone and we come up with a list of Wi-Fi access points, right? And we select one of these access points to associate with, and then they may ask the authentication password and so on. And then we run some DHCP to get IP address and then connect. So one of the first step in this association is called channel scanning. And there are two types of channel scanning. The first one is called passive scanning. The second one is called active scanning. Let's look at first how the passive scanning works. So we have two BSS1 and BSS2. In each BSS, we have an access point 1, access point 2. And this is our laptop that wants to connect to this Wi-Fi network access points. So in the first step, beacon frames sent from access points. So who initiate? The access point initiate this process. So access point 2 and access point 1, they send or broadcast the beacon frames. The second step, the host one, select one of these access point. Let's say it select the access point 2. So that's why association request frame sent from host 1 to the selected access point. And then select access point is gonna send association response frame. And then they are connected. So this is called passive active scanning. Sorry, passive scanning. Let's look at the active scanning. Active scanning, in this case, the steps are given as follows. In the first step, probe request frame is broadcasted from the host 1. So now my laptop or my smartphone, it broadcasts the probe request. And then the access points around this host 1, such as AP1, AP2, they receive this broadcast and probe response frames sent from the access points in the second step. So host 1 is going to select one of these access point. Association request frame is going to send from host 1 to the selected access point. And the selected access point is going to send a response, which is called association response frame, to the host 1. Then the channel scanning mechanism is done. Any questions so far? Okay, so let's have a 10 minutes break.